TCM, or temperature controlled molding, is a new process. And when I say a new process, you probably would think that it is not new. We've done temperature control and molds for a long time. What's different about TCM is the way we control the mold surface heat and do it instantly. It's been a long time in development, and it was very challenging to have a mold surface that really maintains whatever you dictate in terms of temperature up or down, and also in terms of temperature gradients, whether it's a ramp rate with dwell or whether it's descent. And of course, a lot of that depends on whether you have exotherm reactions during that process. What TCM does is it controls the exotherm instantly, and it maintains the profile that you really want to see regardless of the thickness of the laminate. When we do thick laminates, and we say thick laminates, then high fiber volume fraction laminates up to 6-7 inches, we can do that. Is that necessary? In most cases not, but in some cases it's the only way to build a unitary structural part. Large girders, big caps, things like that. And if you have, for instance, a very complex laminate, say one of the larger wind blades. A large wind blade is fascinating from a technical point of view, but it's very challenging because you have so many variables in the laminate. And most of the technology that is being used right now in wind blades is resistive heating. So you basically bump up the temperature slightly, get some reaction going, bump it up some more, and that way you come eventually to complete cure. TCM really shines when you use it with the newer technologies like the Arkema nanotechnology. The commercial name is block builder, but basically what you do with a nanotechnology is you get a complete control over the exotherm process because you're handing over the reactivity to your temperature controlled mold system. And that allows you to gradually and evenly cure a part regardless of configuration, regardless of number of plies, and regardless of thickness. So how does it work? Well, there's a few components, and what we have here are just the lab molds or the training molds. We have a fluid that runs fairly close to the mold surface, and that is controlled by a temperature controller. And we have pumps, we have circulation. Again, that's the idea that we can maintain the surface temperature of the mold at any set temperature. In this case, we have water in the jacket, which means that for all practical purposes, the mold surface temperature is limited to 200 degrees. But for most applications, that is definitely enough. Does it have to be flat? Absolutely not. Fiberglass molds have the advantage that they can be any shape and any size. And one controller can control a fairly large zone. When I say fairly large zone, biggest tables we have running right now are 20 by 60 feet. That's feet, 20 feet by 60 feet. And that runs on a single unit. But of course, you can zone off any mold in sections that are logical and that you'd like to subdivide either because of the laminate or because of production factors, or in the case of a flat table, because of the practicality of not having to heat the entire table or cool the entire table. Again, fluid jacket close to the mold surface, pumps to drive the fluid through there, and the fluid can be water, can be oil, it can be any of the cooling fluids that we're used to use in other industries. Accumulators, heaters, chillers. So that's in a nutshell, the technology. What we're doing with shaped molds right now is make sure that regardless of the temperature you bring to the mold, that you don't get too many variations in dimension, that you maintain your metrology points if you have a very precisely controlled part in terms of dimensions and shape. The advantage of this system compared to other systems that are out there is that it really is stable. So you can dictate what your ramp rate is. You can dictate how quickly a laminate is allowed to exotherm. You can draw a tremendous amount of heat out of the laminate, or you can add a tremendous amount of heat if that is necessary for a certain process. And you can do it fairly quickly. This table works as well for prepregs, because here you got a perfect surface to make your prepregs on. And again, since any mold shape can be made into a TCM mold, you can prepreg with this table. But what I see as a major advantage is that you're not limited to one technology. You're not building the mold for prepreg or for resin infusion. It's a multifunctional mold. So that means that even if your application is only temperature controlled at room temperature, well, we're not talking room temperature on a good day and a bad day. We're really talking temperature control at the mold level. So regardless of what the shop circumstances are, you can maintain temperature control at the mold level. So you can make perfect laminates. So you got vacuum infusion, you got vacuum infusion with nanotechnology, you got high temperature infusion, for instance with epoxy resins in wind blades. You have prepreg capacity, and also you can do dry resin infusion. Dry resin film infusion is much easier with this system, because during the layups and everything, you can set your temperature in your mold to a certain level, which can be the level that that particular material is the most comfortable to work with.